So, a couple of important news items. In checking the calendar, I realized there's an exam on November 14th, which is what, 2 weeks from now, and change. So there's no class on the 12th. It's some holiday. I don't even know what holiday. Veterans Day? Veterans Day. All right. I put up a practice exam on the site, which you will find down here. Exams. Here, practice exam 2. I also put up as a sign of my immense niceness the entire text of the exam. The only thing that's missing, sadly, is the links to the actual code, because I didn't copy and paste. No, because I wasn't going to put that on there. But so you'll know exactly what's on the exam, you just don't know what code is going to be on it. So one part of the exam is where I'm going to have you use the debugger. We're going to have a whole lecture on that on Wednesday, where I'll be running the debugger in front of your very eyes and everything. So one thing that I want to point out is that you do need to practice is you need to be able to take a screenshot as PNG and upload it later. So I will make it so that PNG is going to be one of the accepted file types. So those of you who can only make screenshots as TIFF or as in a Word document or something are going to have to figure out how to do that part. Someone asked if there's a quiz on Tuesday. There's no quiz on Tuesday because on Wednesday I'll be doing that live coding with the debugger. And the quiz question, somehow they already came like a couple of days ago. I forgot to disassociate that. The other thing I want to talk a few minutes about is this very sad story that happened to someone, and I just want to make sure it doesn't happen to anyone again. Let me see if I can find it here. No. That's all the way in the bottom? Yes, okay, here we go. Yes. All right, so here, this poor student had the following really bad luck, that in his, what's that? Come on. Here. He put the cent symbol into his comment, just into the comment. And the compiler gave an error message that says error, say 5 per gallon. And so it didn't compile. And so then, of course, it couldn't pass any of the tests. Why doesn't the compiler like small change? It only likes dollars. As it turns out, if the student had written $0.05, all would indeed have been well. What's the difference between the dollar symbol and the cent symbol? Yeah, so the dollar is a part of the ASCII range, that range of the first 128 characters in Unicode that is the same in essentially all encoding schemes used around the world, whereas the cent symbol is somewhere else. And so what happens is that you have to understand a little bit about character encoding. So I'm going to ramble on for a couple of minutes so that hopefully everyone realizes that there is an issue here. So, so you have these characters. And these days, characters are pretty standardized as Unicode, and it's very rare that you get into a situation where characters are not encoded as Unicode. So we can pretty much assume that on any computing system, you can represent all the Unicode characters. So what's Unicode? Unicode assigns a, gosh, I can never remember, it's 20 or 21 bits. I'll say 20 bits, and if I'm off by one, it's okay. Is a 20-bit code for all characters around the world. So, for example, I happen to know that the uppercase A is encoded as, in decimal, it's 65. Or if I were to then write it down in binary, it would be a whole bunch of zeros. 64, 16, 8, 4, 2, 1. So in binary, it would be this. So oftentimes one writes these codes in hexadecimal, and in hexadecimal it would be 41. So one would write this, you'll often find it written as U plus 0041, and these are the hexadecimal codes. What's important is that every character in the world is one of those 20-bit or so numbers. And there's universal agreement at this point what they are. So if you have, for example, the letter pi, you can look up what its Unicode is. I don't remember what it is. Or if you can look at the cent character, it has some code associated to it. And now the problem is, how do you save these on a file? And the 20 bits is the inconvenient part. If it was 16 bits, then maybe life would be pretty easy. You would just save every character as 2 bytes. And that's how it actually was for a while. That's how it was at the time when Java was invented. But then they ran out of space. 16-bit is just enough for 65,000 characters. And you might say, why are there all these characters? I mean, what's wrong with 26 uppercase and 26 lowercase letters? But it's the ideographic languages, Chinese, Japanese, Korean, that do you in. That at one point they did a bunch of counting, and they said, oh, 65,000 is going to be enough for all of the ideographic characters. And then when they counted again, they found another 20,000 characters somewhere, and it blew the bank. So we're now stuck with the fact that, as it happens in the world, that you need a 20 or so bits, and it's really inconvenient to put them into 8-bit bytes. And there are a number of different schemes that were designed for this. And the most popular scheme is called UTF-8 for Unicode Transformation Format, 8 bits. And it uses a variable encoding where some characters are put into 8 bits. Some characters are put into 2 bytes, or 16 bits, and some of them into 3, and that's good enough for everything. So it's this variable length encoding. They made it so that the ASCII characters are the ones that start with 0, and then they have whatever. They are just used as 1 byte because so much of what people write is English, and so this way you can take any English document as long as it contains only dollars and not cents, and write it down as a sequence of just 1 bytes. And then you need more for the others. And that's a very sensible scheme that is really almost universally used. There are 2 exceptions to this. To this 3 exceptions, I should. 2 kinds of exception. Exception kind number 1 is in both Java and Windows NT and its derivatives such as Windows 7, Windows 8. Those 2 systems had the misfortune of having been born when one thought that 16 bits would be enough for all of Unicode, and they will use 16-bit Unicode internally almost everywhere, except, of course, when they have to deal with those 20,000 or so Chinese characters that don't fit, and then they have some ugly hack to deal with it. And it is pretty ugly, and if you have to process text that contains those, what's called those supplemental characters, then it's no fun. We don't fortunately have to do that in this course, so we don't have to worry about it. So that's the exception number one. Exception number two is that two loser legacy operating systems don't even bother to do anything with the versions that they sell in the United States. Those two systems are Windows and Mac OS, for reasons unknown to any sentient being. When you get a computer that runs either Windows or Mac OS, the American version, they use an encoding system that can only encode 256 characters by default in every file that they write. Now, I didn't really care about that because I said, as long as the software that you use on those systems, as long as the software that you use does the right thing and pick the right encoding system, we're fine. Both BlueJ and NetBeans say, yeah, I may be running on stupid Windows, but I'll still use UTF-8. Not a problem. If, on the other hand, you use Eclipse or Notepad or any number of other pieces of software that I told you not to use, then it's up to you to find out how to make it save UTF-8. And so that's really what happened to this poor student. So, and so really, if you use Eclipse, it will store a cent sign in a way that's incompatible with UTF-8, and it will not be able to store, say, the letter pi, because it goes beyond the range that it can handle, unless you go into the configuration of Eclipse and say, I don't want this stuff, give me UTF-8. With Notepad, I don't actually know how to make it do that, but it's not really worth it. So really the moral is that when you send a file anywhere, you need to know what the character encoding is. And it's something that we're going to be practicing at great detail next semester. Right now, like I say, you're safe if you use BlueJ. If you use anything else, it is kind of your responsibility to figure this out. What if you're nervous about figuring it out? The first thing that saves is to know your ASCII character range and stay away from anything that's outside ASCII. But that means that you'd have to know that the cent symbol is not ASCII. The rule of thumb is, if there's a key for it on your keyboard, and if you have an American keyboard, then it's ASCII. So there's a key for dollar, but there's no key for cent, and so that kind of tips you off. It is a totally vexing issue that 10 years ago no one cared because our computers weren't connected to each other. And so it didn't really much matter as long as it ran fine on your machine, and then you printed something out on your machine and it was good. Nowadays, all of the computers are connected, and you send the stuff to somewhere else, and they need to know what the character encoding is. Now you could say, why can't they put the character encoding into the file? And in some files they can, like in a Word document, there's room for it. But in a plain text file, there's no room to put any information about the character encoding. And so it is totally important that everyone agrees on it. And so the way to agree on it is for everyone to use UTF-8. And that may also explain why Windows and the Mac, they don't really care about it so much, because normal users of a Windows or a Mac machine don't exchange text files with each other. They would exchange like a Word document, where this is not a problem. The Word document will contain as part of its metadata what the character encoding is. It's just us poor programmers where we exchange text files all the time, and those text files have no indication whatsoever. So I bitched about this on the discussion group of the faculty, and one of the faculty members said, well, why didn't you make the web application so that it knows when someone connects to it what the operating system is on the other side? You can actually do that. But in this situation, it doesn't work like that, because you submitted your homework to Canvas, which stripped off that information, but bundled up everything in a giant zip file, which now could have contained text files with 3 different character encodings. There was no way to recover it. So be super, super careful about this. It is a vexing issue. And it'll happen when you have your first server-side projects where you'll deal with it again. And you'll remember that I ranted for 10 minutes and you didn't quite know why. All right. Thank you for letting me rant. Any other questions on homework 8? The solutions for homework 8 are out, so you can have a look at those. Anything on homework 9 that I want to say real quick? minus. No. No, homework 9 is still easy. Homework 10 is hard. All right. Let's go into lecture. So we're going to get into arrays. Arrays are hugely important. Anytime that you want to store more than a number or two, you're going to need an array. So an array is a sequence of values of the same type. So here I have an example. I want to store 10 floating point numbers for whatever reason. And so the way to make an array is with the syntax here. I say, give me a new array. You don't see the word array here anyway. You have to guess it from the brackets here. I want an array of floating point numbers, of doubles, and I want 10. And so here the brackets tip you off that what you want is an array. What do you get? You get a thing that has 10 slots suitable for holding 10 numbers. When you create the array, everything is initialized with a default, which depends on the type of what you have. If you have an array of numbers, integers or floating point numbers, they initialize with 0. If you have an array of booleans, they initialize with false. And if you have an array of objects, they all start out their life as null. And you'll see in the next slide how you can change those. So you use arrays anytime that you want to collect a bunch of data points. And it's totally obvious why you might want to do this. Every student might have a bunch of scores. You would store them in an array. You might have a bunch of temperature readings. You would have an array for 12 elements, maybe one per month, or 24, one per hour, or whatever your application is. So if you have like a bank statement, you might have an array of items where each item describes a particular transaction. Or on an invoice, you would have an array of items. In a bank, you might have an array of bank accounts. Anytime that you want to collect a bunch of things, the array is like the easiest way of doing that collecting. So one thing to notice is just like objects and object variables don't store the actual object, but a reference to the object. The same thing is true for arrays. So values is a reference to the array. And if I copied it, and I'll have a slide about that later, then I could have another reference to the same array. So you can kind of think as an array as an object that has a somewhat different structure than most objects. Regular objects have fields, but arrays have these slots that contain values of the same type. So an array of doubles contains only doubles and nothing else. You use this bracket operation to access an element. So over here, I say values bracket 2 equals 2995, and then it puts the 2995 into the slot number 2. You'll notice that just like with strings, the index values, the position values start at 0, not at 1. And that's just the way it is. There are advantages and disadvantages to that, but we have no control over it. So if you wanted to read the value, you would use it the same way. You would say print system.out print on values 2. So the values bracket 2 can read something from the array, or if it appears to the left-hand side of an equal sign, it can write something to the array. So yeah, here we see. So when you have an array, you can try to remember how long it was. Like over here, I created the array with 10 elements, and then of course I know it had 10 elements inside. But it often happens that you have an array and someone handed it to you, and you don't quite know how long it was, but you can ask it. So here's my array values, and if I want to know how many elements did it have, then I do the dot length. Weirdly enough, dot length is not a method. It should be a method. And it was just an oversight at some point where they said it's a field. It's a read-only field, and it's a common error for students to accidentally put the parentheses, but then the compiler will tell you and you take them off. So you just have to remember this exceptional behavior that length, even though it should be a method, just like size or length of a string is a method, right? But for arrays, it just isn't a method. It gives you back the number of elements. So just with strings, index values go from 0 to length -1. The same thing is true for arrays. Start at 0. The last valid value is length -1. And then if you access the actual length, then you'll get an error. So over here, I'm making an array with 10 elements. And then when I access the slot number 10, that doesn't exist. We only have the slots from 0, 1, up to 9. So if you do access the 10th slot, you get an array index out of bounds exception. Your program dies, and you'll see where that error happens. Exceedingly common, exactly the same thing as the string index out of bounds exceptions that you've undoubtedly encountered in the previous homeworks where we did string manipulation. So in a way, you can kind of compare arrays with strings. They're very, very similar. An array collects a bunch of things, often numbers, and a string collects characters. And really pretty much the same way. A string is a sequence of characters. An array is a sequence of values. A string has a length. An array has a length. With a string has positions that start at 0. Arrays have positions that start at 0. The only thing that's different is the syntax. With strings, to get at the ith character, you would say string char_at of I, or string dot substring of I plus 1. With an array, that's a little bit easier. You can say ARR bracket I. So you have this very convenient bracket notation to get to the ith element. The other difference is, of course, arrays are mutable. You can change what's in an array, whereas you couldn't change what's in a string. With a string, you'd have to build up a new string. With an array, you can just put something into the ith slot, and then that changes the ith slot. And I guess the third difference is arrays can hold anything, whereas strings can only hold characters. There are some programming languages where strings and arrays are more closely related than in Java. So in Java, they're conceptually the same, but the syntax and the underlying implementation are different. But still, it's a good idea to think of them as being somewhat related. Now, a big limitation of arrays is that arrays have fixed length. When you make an array, you have to know how long you want it, and you can't change your mind later. And that turns out to be painful in many applications. Suppose, for example, I write an application that handles student scores. And then I have to know how many scores will there be for a student. And how many scores should I provide for? 15? What if there are 20? What if there's only 5? So it's a little hard to do. If you change your mind at some point because you add another quiz, and now all of a sudden it's 16, then you have to work. There are ways around it, but it's generally uncomfortable. And that's a reason why I'll come to that in a minute. Why we want to look for an alternate data structure that's like arrays, but that's more dynamic in that regard. So arrays are great in Java, except for this one limitation. All right, here a bit more syntax here. So over here, you see that I have an array of 10 integers. And notice that on the right-hand side, I have the constructor invocation. This constructs an object. I want to save it, and so I save it here on the left-hand side in an array that I call numbers. And notice the type of it. The type is all the way to the left of the name, and it is int brackets, an array of integers. So if I wanted to have an array of strings, you see that down here, it would be string bracket. To construct the array, I again use the string bracket, but inside the brackets, I have to put the size to put 3 strings. So at first, when you use that syntax, it takes a bit of getting used to exactly where the pieces go, and after a while, it becomes second nature. Now, over here, the 10 here is, of course, what is it? It is a magic number, right? Why exactly 10? And so you always want to use a constant for that. So over here, I call it numbers length. And it actually is not a bad idea because it's a companion to the numbers array to follow that naming scheme. Unless there's a better reason why it's 10, right? So you might, for example, if you store one input per month, then you could put number of months per year, or just months per year or something. But if you have no other information, this is a reasonable naming scheme. Now, you are allowed a little bit of dynamism when you make an array. You can set a variable, it doesn't have to be a constant, and then use a variable, or just any expression for that matter, inside here. So what this code does is it presumably asks the user, how long should this array be? Reads in the input, and then it makes an array of that length. And so if the user in a given day types 10, that's fine. If on the next day he types 500,000, that's also fine. It makes an array of the appropriate length. The only thing is, after you've created the array, then its size has been frozen. If you know what you want to put into the array, you can specify it with the brackets notation that you see here. You simply put an opening and a closing brace, and inside there you put all of the elements that you know you want in there. In this case here, you don't have to specify the length. Why not? It can count them, right? The compiler can be useful enough to just count how many elements there should be. And so you simply say it like that. It knows the element type because it sees over here. It can count the numbers, and that's that. All right. So here we have an array of strings, just to show that the array type could be anything. Here we have another way of initializing an array of strings with these three here. And you see, it's the same notation with the braces. It's just strings here, not numbers. Finally, the types of arrays matter. Here I'm making an array of integers, and I'm trying to assign it over here to an array of doubles. So notice here it's int, and here it's double. And that's an error. You can never make that assignment. Even though an individual int could be moved into a double, an array of ints cannot be moved into an array of doubles. The types need to match exactly. All right. Let me make this a little smaller so you can see this. All right, so when I is 0, then A0 is set to, oh no, not A, values, sorry. Then values 0 is set to 0 plus 1 times 0 plus 1, that's 1. So in other words, I've already eliminated options 1 and 3. There's no option that says whether it's something else. So either it's 2 or an exception was thrown. So let's see what happens all the way at the end. Values.length is 10. I is less than 10, so that means the last thing that I assumes is 9. At that point, values 9 is set to 10 times 10. That's 100. And that's fine, right? Values 9 is still legal. Values 10 would be illegal, so it's got to be this one here. And yeah, so that was the overwhelming favorite, so we're good. All right, so hopefully here we have something that's a little harder. All right, so over here, so why is there 0 in AF0?
Because that's what's initialized.
Yeah, they're always initialized with 0, right? A1 is also going to be 0. All right, so look at B.B10. Oh dear. So here I get an array index out of bounds exception because, of course, this thing only has values B0 to B9. B9 is still fine. And over here, oh, that is interesting. So here I get a null pointer exception. And so the reason I get a null pointer exception here is that C is initialized as null, and no array was attached to it, right? There was no equals new double afterwards. So had that been there, it would have been fine, but there wasn't. So, and now here's this cryptic comment that says, CodePad variables are automatically initialized in the same way as instance fields. Why did they put that? So when I looked at this code here, my idea was that this was what would be inside some method. So that C would be a local variable. And when you have a local variable, what would happen in this case? So the compiler looks at C. Will it compile this line? Is this legal? Notice it's not initialized. Is it legal to have a local variable that's not initialized? Yeah, it's perfectly legal, right? You just have to initialize it before you use it, but it doesn't have to be in the same line. Now here you do use it, and what's the compiler going to say? It was not an initialized variable, you were not allowed to use it. So if this was a local variable, then the correct answer would have been 4. If it was an instance variable, instance variables are initialized with null, then the correct answer would have been number 1 prints 0, number 2 and number 3 throw an exception, which wasn't one of the valid choices. So we know ex post facto it must have been a local variable. And let's see. I think most people got to that point. Yeah, now some people said number 2 and number 3 don't compile, so I do agree that number 3 doesn't compile, but number 2 will compile fine. It sounds unfair. Couldn't the Java compiler say, well, obviously this thing must throw an exception, but the Java compiler does not do any tracking between successive lines. So each line kind of lives alone for it, except when it comes to actually identifying uninitialized variables. So this will compile, and it'll just not run. In practice, it doesn't happen often enough that it's worth checking it. All right. So once people learn to use arrays, there is a short period where they use arrays for everything, and where an ugly phenomenon known as parallel arrays comes up. So suppose you have a bank application, and we have 10 bank accounts. Each bank account has an account number. Each bank account has a balance. That's when people who just discovered arrays will often do this construction, where they make an array of 10 account numbers and a parallel array of 10 balances. And then the actual information for one account is separated between these two arrays in a slice of that I've painted here like that. So the obvious remedy is to instead make an array of objects where each object has all of the information together. Now, you've started out learning objects before learning arrays, and that's probably a very natural way for you to operate anyway. By now you know that if you have to gather a bunch of stuff together, you stick it into an object of a class, and then you just make an array of those objects. There's no difference between an array of numbers or an array of bank accounts conceptually. And so that's a very natural thing to do. On the other hand, some people don't start out with objects. They first learn arrays, and then they learn objects much later, and they're fairly likely to run into this mistake. All right, now I grumbled and said arrays have this disadvantage that they don't grow on demand. Once you run out of room, then you have to labor hard. There is a class that's designed to make that part easier, called an array list for a reason that we'll see in 46b. So an array list is just like an array, except it can grow and shrink. And sadly, it has a somewhat different syntax. So we have to learn two sets of syntax to essentially achieve the same thing. But that's life. So the array list supplies lots of useful methods. You can insert elements. You can remove them anywhere. Arrays don't have those methods. And arrays lists, like I say, they can change their size as needed. And so as a general rule for doing the kind of programming that you do to solve actual problems, you will almost never use an array, and you will almost always use an array list. So array lists really are important. I'll come to there are three reasons to use an array, and I'll come to them at the end of the lecture. But for everything else, one uses an array list, so it's well worth knowing the syntax. Now, array lists are a little bit more regular for you because they are classes, and so the syntax is almost exactly like for any other classes. For example, down here, to add an element to the end of an array list, you just use the add method. It sticks it right to the end. And it's a regular method called names.add. There's no brackets or anything. The only part of the syntax that's funny are these angle brackets here. And notice they're angle brackets and not round brackets. And they enclose the type of the elements. So you can have an array list of any type, and an array list of strings, you put string inside there. An array list of bank account would be array list, angle brackets, bank account. When you construct an array list, you don't have to say how big you want it. You typically have an array list that starts out at size 0, and then you call add to add elements to the end, as many or as few as you want. Then the size method tells you how many elements you have added in case you've forgotten. So the syntax is different, but not irregular. You simply have to remember array list is a class. Then it has this funny type argument, and the parentheses here are, of course, because those are the constructor parameters. This one here doesn't take any. The slides don't say it because Java 7 came out after the slides were made. In this day and age, you can actually omit one of the types things. Notice that you say string here and you say string here, and that's like saying it twice, And so nowadays you don't have to do the first one. You can say array list angle bracket names equals new array list of string. So notice that over here there's no type. The compiler will infer the type by looking at the type on the right. Now that's a minor saving. It saves you 5 characters. See if you like it. It'll work with your Java 7 compiler. If you're stuck with Java 6 on the Mac, then it would not work. So the book doesn't use that shortcut yet, but you'll find it all over the place. Okay, so he has add. Adding simply adds elements. So over here, I already added Emily and Bob into this array, and now I'm going to add Cindy, and then Cindy just gets stuck at the end of the array list. So it's really nothing to it. To retrieve elements, you don't use the bracket notations, but you use a regular old method call. The method to read is called get. So get of 2 gets the element at position 2, that's the third element of the array list. You get the same old bounds error that you would get with brackets in an array. So over here, if I have an array of names, I ask what's its size. Oh, notice it's called size and not length. So for an array, it's called length. And for an array list, it's called size. Why? It's just to keep programmers on their toes. So there's absolutely no rational reason why they changed it from one to the other. They just did. So it's, irritatingly enough, it's length for strings. It's length without anything for arrays, and it is size for array lists. It's annoyingly inconsistent, and after a while you get used to it. So here you again have that common bounds error where if you try to make a lookup at the first invalid index, the one that's actually the size, then you get an exception. To set an element, you have to use the set method like this, and from an object-oriented point of view, it's very logical. You have the array list names, and you call the set method, and you give it 2 pieces of information: where to set something and what to set. Do I have a picture? No. I'll just draw the picture. So what it does is, what was it before? Oh, I don't know. Ann, Beth, and Cindy say, when you now execute this call, then it wipes out what was here before and puts in the new values. And again, the position values are 0, 1, and 2. What happens if you call names set 3? In this example? Let's say we want to set 3 to David. Then it'll say, no, I only take girl names. Why doesn't it work? So right now this thing is only 3 elements long, and so the 3 would be an invalid position. How can you add David into names? Exactly. So when you call names.add David, that works great. Then it'll dynamically make this thing bigger, put David in here. All right, you can remove elements, and you just call remove, and yeah, I have a picture here. So here I'm going to remove 1, so 1 is going to be this one here, and then when I call remove, it's gone, and the other ones slide up by 1 position. So it simply takes out 1 element from the array list. It's very simple. So here a bit of syntax. So here you see again how I make an array list of strings. Currently it has size 0. I call add on it a couple of times, and now it has size 2. Now for debugging, this is very useful. You can just print names. So actually, let me do this here real quickly in BlueJ. To use an array list, I have to import it. Also, when you import it, you don't import it with the brackets. You just import it just like this. Now I can do this thing here. Add these guys to it. And now when I print out names, well, that was, oh, I see, because of, I do it like this, system out. Print on names. Then you see them printed out here in this neat little bracket notation. Yes? It is now, because I'm reading it from there. It wasn't there a couple hours ago. So go to the index page and hit refresh on it. I had bad links on the index page this morning. So refresh the index page and you should be good to go. Yeah, sorry about that. All right, so I wanted to point out that it prints an array list by simply printing all of its elements, which is very convenient for debugging. And now you would say, well, what else would it do? Well, let me show you what else something would do. Notice you have an array, not an array list, of integers. And now for debugging purposes, I want to print it out. And here it is. Bizarre fact of the day, number 93. When you print out an array, you get what's called its hash code, which is never what you want. And that's there for historical reasons. So if you actually wanted to see what's inside an array, you have a couple of choices. You could write a loop. And here you see them printed. But that's a lot of typing, right, just to print them out. The other way you can do it, you can import Java util arrays, and you can print, I don't even have to print it, I can just do it here. There's a helper function called arrays.toString that turns an array into that same convenient representation as an array list. Well worth to know that trick for debugging. Arrays.toString, so make a mental note of that. Next time that you just want to know what's inside an array for debugging, print out that thing. All right, with an array list, that part comes for free. And then we have a couple of add, remove, set. So notice the difference between add and set is that set overwrites an existing element, add adds a new element. Doesn't have to be at the end. Over here, I'm adding it at position 1, and then it shifts the other ones up. So you can think of add as being the exact opposite of remove. Then you have set and get. That's just the way it is. So you can work through the remaining ones yourself. Okay, never mind this stuff. Yeah, let's just work through this one here real quick. Shouldn't be too hard. Come on, this can't be so hard. We're calling add, and remove. How many elements do we have left over? 2, right? If you add 3 and you remove 1. So it can't possibly be 1 or 2. And the only question is whether it's this one or something else. So let's see. So we add A. That's not position 0. We add B. Well, when we add it at position 0, then it looks like this. It gets shifted up. We now add C. And now we remove position 1, which is this one here. So it is this one. Yeah, and that's what everyone said, so. All right. And that is the last question I had here. So, like I said before, as a general rule of thumb, when should you use an array and when should you use an array list? As we'll see in the next lecture, array lists of numbers are a little bit funny because in Java, numbers are not objects, and so you have to wrap each number into an object. So array lists of numbers are a little awkward. And so when you deal with pure numbers, you often just use arrays. The other thing is if you know a priori exactly how long your array is, if you exactly need to deal, say, with 12 months of the year, then there's no downside to using an array. It has a slightly easier syntax with the brackets than the calls to get set. And so people tend to use arrays for that if they know what the number of elements in there. If you have an array that's not numbers, strings or objects, which is what usually is in applications, if you don't exactly know how many you need, which is usually what happens in practical applications, you would always use an array list. There's only one other situation in your life when you will need to use an array, and that is when your instructor tells you to. And that'll happen to you more often than you think, because, and this is one of my many pet peeves, apparently many times the instructors who teach this material are not actual programmers, and they seem to think that arrays are somehow more natural or better than array lists. And so I've seen many times some exercises that were actually quite a bit more complicated because they were done in terms of arrays. Now, I guess for the next couple of homeworks, I must confess to be one of them, because when you look at the first homework with arrays / array lists, which is 10, I have an array of bank accounts, and here I have an array of numbers. I guess because that actually is sensible. And here I have another array of numbers, which I guess is also sensible. So the first one maybe I should have made into an array list. All right, so any questions so far? Then I will use a few more minutes to go through a couple of the things that I spotted on Piazza, just for everyone's amusement. So again, I want to say if I picked on a particular person's question, it was not to say anything bad about that person. It was really because it was a good and useful question. So I noticed a bunch of questions that had to do with logic. So here we get a question that said, why would Piazza say timed out after 30 seconds? That's when you have an infinite loop. So you just have to imagine what happens. You submit the job, and Piazza then, NetBread runs it. And if you did write an infinite loop, what's it going to do? I mean, it has to kill it. Because if enough students submit infinite loops, eventually it'll consume all the processing power of the server to run through those infinite loops. So NetBread will take any program and kill it after 30 seconds. And so when you get that message, the overwhelmingly likely thing is that you did in fact have an infinite loop, or at least a computation that took like an incredibly long time. So the student didn't post the loop, so we don't get to see that. So let me get to the next one. All right, now here we have a student who has an infinite loop. This is the one that I was looking for. So look at the loop carefully here. Some student nicely enough extracted it. And so this is the loop here. While the x position is not equal 0, y position not equal 0, x position not equal max, y position not equal max. And this is a super common error. What's the error? So this is, we want to go until we hit a wall. They should be ands, yes. In fact, this is such a common error that let me show you this. Here. Your textbook has a section called Common Error 5.5, and the common error is called confusing and ors. Okay, it happens all the time. So these common errors are there for a reason, so that they list those things that are kind of common. And so it's very, very common for students to get confused about ands and ors. And whenever I lecture about this, I say, it's kind of hard to imagine why this would be confusing, because it should be totally obvious whether it's and or. So here, you look at these examples here from the tax code. So it says that you can claim single status if you were never married, you were legally separated or divorced, you were widowed. Is it and or? Are you either? Maybe you're trying to make the case for me that it is confusing. I mean, you can't be at the same time never married and separated or divorced, right? So it has to be or. So here you have an example of an or. And so now let's look again at the question here. So what the student was after is to say, we know when we are at the boundary. We're at the boundary if x is 0, if x is 0, or if y is 0, or if x is the max, or if y is the max. And that's when we're done. So when you invert that condition, two things happen. Every one of the equals turns into a not equal, and every one of the ands turns into or. That's what's called De Morgan's law, and it's also there in chapter 5. Here, as a special topic, because some people find it confusing, and some reviewers made me put it as a special topic, which is too bad because it's really useful. So read that section on De Morgan's law. It is a super useful section to know. This is in chapter 5. And it really is something that every programmer should be aware of. All right, so the other thing is, just in general, when I find myself with a condition like this, and my program acts up, that is, I know by instinct, that is one of the things where I home into. It is very common in such a long and complicated situation to be confused about the ands and ors. So it's worth looking out for this. So I noticed that 51 views, but that means there are 100 of you who haven't had a look at it. So be sure to do that. All right, that's all I can think of right now. Okay, I can't find the other one. Any other question? Then I'll let you go early, and I can go to my meeting. All right, thank you.